Hello, welcome. Again, we are covering the subject compressible fluid for Gate Aerospace, IS and IFS. So we have covered first topic, that is definition of compressibility, and then we started the flow regime. So the first flow regime is your subsonic flow regime. So we discussed some definitions in the previous video. These were free stream and streamlines and then Mach number. So these properties will be used to define the different type of flow regime. So first is your subsonic flow regime. So this is your subsonic flow regime. So here we can see that the m infinity is zero point 0.8, which is less than 1. So it is subsonic, and here also local Mach number is also less than 1. So that's why the flow everywhere has the Mach number less than 1, or the flow everywhere is subsonic flow. So here m is less than zero point 0.8, here m is less than 1. Here Mach number when it passed over the air pole increases, but it remains less than 1. So that's why this area or this regime is called subsonic flow regime. Okay. So other properties are also there, and I will read this. In subsonic flow, the local Mach number is everywhere less than unity. And second part is, this flow is characterized by smooth, streamlined and continuously varying properties. So these are the smooth streamlines here, and here when passes the airfoil or aerodynamic body, then the properties and Mach number changes continuously, but Mach number remains less than 1. It is the Mach number is continuously changing. Here it is different, here is different, here is different, pressure here is different, here is different, here is different. Okay, so that is defined by continuously varying properties. Continuous means there is no sudden variation, there is continuous. Here some Mach number increasing, here also, here also. It is continuously increasing, continuously varying properties. Okay, the initial next part is the initially straight and parallel streamlines in the free stream begin to deflect far upstream of the body. That is, the flow is forward of the presence of body. Suppose the velocity here is v infinity, okay, and Mach number is less than 0.8, and here aerodynamic body is placed. So when Mach number is less than 1 or less than 0.8, or there is subsonic flow, then the presence of body is felt by the flow, and the flow changes its direction continuously like this. Okay, so the presence of body is forward. Okay, warning is before the flow reaches the body. Okay, so that's why the flow changes its path continuously like this. Okay. So this point is, I am reading this point again. The initial straight and parallel streamlines in the free stream begin to deflect far upstream of the body. So this is your upstream. So it has started begin to deflect here. Not they are deflecting here suddenly. They are continuously deflecting. This is the presence of, that means the flow is forward of the presence of body. Next point is, as the flow passes over the airfoil, the local velocity and Mach number on the top surface increases above their free stream value. However, if m infinity is sufficiently less than 1, the local Mach number everywhere remains subsonic. Here you can see that the Mach number will increase from less than 0.8 to nearly 1, but it will be less than 1. If this m infinity is very less, then it will not reach m is equal to 1, or the flow will remain subsonic everywhere. Okay, the local Mach number everywhere will remain subsonic. For airfoil in common use, if M infinity is less than equal to 0.8, the flow field is generally completely subsonic. So if this Mach number is less than 0.8 or equal to 0.8, then the Mach number here will not go up to 1. So this flow can be considered as subsonic flow or subsonic flow region. So this is your velocity and these are the streamlines